Hello, ladies and gentlemen. Welcome to our virtual classroom. And today we are going to be talking about prime factorization, prime factorizations. Let's just jump right into it. Let me share my screen. And I encourage you to take out your physical notebook and begin by copying down the title at least. I encourage you to pause this video and please copy this down. Copy SB 2-1. The title is Prime Factorization. The page numbers 27 through 29. The date. And I forgot to write the big number 5 up here because this is actually our 5th lesson. So please put a big 5 on top. And then the numbers for our homework today, which is going to be numbers 1 through 4. And then number 6. So again, I encourage you to pause this and copy those down and then resume once you are ready. So having copied that down, ladies and gentlemen, let's begin. Prime factorization. Prime factorization. And if it's really that difficult to follow with my handwriting, it's prime factorization. Prime factorization. Anyways, if you notice, prime factorization is really a compound phrase, if that's even a thing, meaning that we have the word prime and then factor, prime factor. Okay, so let's talk about what a prime number is. Okay, let's break that down. The word prime, that is a prime number. That's where that comes from. All right, and a prime number, and I'm just going to type this, what I wrote down in my own handwriting. I'm going to type it here on the side for those of you that have a hard time seeing it, and to elaborate a little bit on what that says. So a prime number is a number greater than 1, than the number 1, that has exactly 2 factors. 2 factors. Those factors are 1 and itself. So again, a prime number is a number that has exactly 2 factors, and those factors are 1 and itself. Mr. Lugo, what is a factor? We're going to get into that in a little bit. We did cover that last week. For now, know that it has something to do with multiplication. We'll cover that in more detail in a second. To best understand a prime number, I'd like to go over examples of prime numbers, beginning with the smallest of all prime numbers, and that is the number 2. Okay, it has to be greater than 1. And by the way, these are all whole numbers, meaning we're not going to have any decimals. We're not going to deal with decimals at all when we're talking about prime factorization and prime numbers and the like. So that makes 2 the smallest prime number. 1 is not a prime number. 1 is not, it doesn't apply to this. So we start with 2. And if we go in order, without skipping any prime numbers, they start like this: 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And then you keep going with 31, followed by, I believe it's 37, and then 41, and I believe it's 47. Yeah. Anyways, you keep going. But what do these numbers have in common, ladies and gentlemen? Well, consider the number 5. Ask yourself, what numbers can I multiply to get the number 5? I mean, the only numbers that come to mind are 5 times 1. Notice how the only factors are 5 and 1. You can't divide it further than that. You're just gonna, it's just 5 and 1, 5 and 1, 5 and 1. That's it. Same thing for the number 7. 7, I can't evenly divide it into anything else except for 7 divided by 1, which is 7. I can't break it down any further than that. Now, what do I mean by break it down further? Well, like the number 10, I can break it down into 5 and 2, right? But I can't break down 2 anymore. That's a prime number, except 2 and 1, but that's it. And then 5, again, I can't break it down further. So that is also a prime number. That's what I mean by prime numbers, where you can't break it down further. The opposite of a prime number is a composite number, which isn't written down here, but let me write it for you. Just for those of you that didn't know that or did not remember that. And so I can contrast this. So in contrast, when we have a composite number, and let's do that in orange over here. If we have a composite number, just so you know what I'm talking about. A composite number, you can break it down further. You do have more factors than just one in itself. As an example, I mean, between 2 and 3, you have the number 4. And the number 4, I can break it down not only 1 times 4, though that is totally possible, but the number 4, I can also break it down into 2 times 2. So obviously, it's not just 1 in itself. I also have the number 2. The number 6, which is between 5 and 7. 6, I can break it down not only into 6 times 1, though that is, of course, possible, but I can also break it down into 2 times 3. So I have more options. I can break it down differently. The number 8, again, not just 8 times 1, but I can do 4 times 2. I can break it down. Number 9, even the number 9, it's not just 9 times 1. I can also break down 9 into 3 times 3. So as you can see, composite numbers can be further broken down into something other than just 1 in itself, but prime numbers can only be broken down into factors of 1 and itself. Okay, you can't go any further than that. Okay, we keep using this word factor. And it's in that title, Prime Factorization, prime factor. So let's review what a factor is. So a factor, ladies and gentlemen, is simply, when I'm talking about factors, I'm talking about numbers, or the numbers being multiplied. Numbers being multiplied. And we had this example last week, if you remember. I gave you the example of 2 times 3, which equals 6. Both 2 and 3, ladies and gentlemen, are factors. Those are the numbers being multiplied. Anytime you hear the word factor, we are dealing with multiplication in some sort of way. And of course, 6 would be considered the product. But again, I want you to focus on factors. So in essence, today, as we're talking about prime factorization, we're going to deal with the multiplication of prime numbers in a specific way. So prime factorization has to deal with multiplication of prime numbers, but how and why? That takes us to our main definition today, which is prime factorization. And again, anytime we have a definition, I encourage you to pause the video, copy it down, and then keep going. And so if you haven't done so, do that right now. Pause the video, copy these things down, and then let's keep going. And so let's go down to prime factorization. Can you scroll down a little bit? So prime factorization. So putting those things together, then prime factorization refers to the prime numbers that will multiply to produce a specific, I'm going to put a specific, it says product in my own writing here, but I'm going to elaborate a little more, to produce a specific composite number. The prime numbers that will multiply to produce a specific composite number. And still another way to think about it, when I'm talking about prime factorization, is simply taking a number, a composite number really, a number that is a composite number, broken down into its prime factors. And that is what prime factorization is. We're going to start with a composite number, and we're going to break it down until all that is left over is its prime factors. Factors that are prime numbers is what I'm saying. Factors that are prime numbers. All right, so let's do that. Let's start with a composite number like the number 12. Like the number 12 as I have right here. And let's break it down. So 12, obviously 12 times 1, but that doesn't really help. So let's do 6 times 2. 6 times 2. Now, out of 6 and 2, 2 is already a prime number. Remember, I'm breaking it down until all I have is prime numbers. So because 2 is already a prime number, I'm going to leave it like that. I'm just going to circle it. This is a prime number. That's what I'm saying. But 6 is not a prime number. It is a composite number, meaning I can break it down further. So 6 can be broken down into 3 times 2, both of which are prime numbers. I cannot break them down further except into themselves in 1. So that's it. Notice how nothing is left over except for prime numbers. So it would be said that the prime factorization of 12 is 2 times 2 times 3. Again, these are prime factors because they are prime numbers, and factors because I can multiply them. And when I multiply them together, they produce the composite number of 12. 2 times 2 is 4, right? 2 times 2 is 4. And then 4 times 3 is 12. If I go the other way around, 2 times 3, that's 6, and then 6 times 2 is 12. So I know this is correct. Now, well, what if I went a different direction? Let's start with 12 again, but this time let's go with 3 times 4. 3 times 4, because 3 times 4 is 12. Again, I want to break it down until we only have prime numbers. So 3 is already a prime number, so I'm going to leave that alone. But let's break down 4. 4 is not a prime number, it's composite, so I'm going to break it down into 2 times 2, both of which are prime numbers. All I have left are prime numbers. I can't do anything else. And so that's it. The prime factorization of 12, again, is 2 times 2 times 3. That would be my answer, 2 times 2 times 3. Okay, so let's look at a little bit more complicated number just to see how this would actually play out. So let me clear all this. What about the number 84? As you would see down here, there's different ways of breaking it down. That's why I wrote it 3 times. There's actually like 5 different ways of breaking it down. Let's consider the number 84. 84. Well, one way to break down 84 would be 7 times 12. Again, I'm trying to get the prime factorization. I want to break it down to the point that I only have its prime factors. Okay, so is 7 a prime factor? Yes, I'm going to circle it. I'm done with that. But what about 12? 12 is not a prime factor. It is composite. So I'm going to break it down. Let's do 6 times 2, or 2 times 6 is the same thing. 2 times 6. And we know that 2 is prime, so I'm going to circle it. And you always want to circle it immediately so you don't forget about it and so that you don't do anything else with it. You're done with it. And then 6, I can break that down into 2, which is prime, and 3, which is prime as well. And that is it. I have broken it down to its prime factors. So I'm going to write them down. 2, and we are multiplying, times 2, times 3, times 7. This is the same thing as 12, but 12 expressed as only prime numbers. How do I know that? Well, 2 times 2 is 4. Okay. 4 times 3 is 12, and then 12 times 7 is 84. This works out. I can go the other way. 7 times 3 is 21. 21 times 2 is 42. 42 times 2 is 84. Again, it works out. Well, what if I went a different route? Let's say I did 84, and I expressed 84 as the product of 21 and 4. Because 21 times 4 is 81. If you don't believe me, work it out on the side. Well, neither of these are prime, so I can further break them down. 21, oh, I should not circle it. It is not prime. 21, I can break that down into 7 times 3. 7 is prime, 3 is prime. And then 2, I can break that down into 2 times 2. 2 is prime and 2 is prime. I'm done. They're all that is left over is prime numbers. So that would be 2 times 2 times 3 times 7. And that's another way of writing times, just a dot in the middle. We'll get more into that later. It's the exact same thing though, ladies and gentlemen. 2 times 2 times 3 times 7, 2 times 2 times 3 times 7. I encourage you to write them down in order. So write the 2s and then the 3s and the 5s and the 7s, just for the sake of keeping it organized. But as you can see, it's the exact same answer. Let's do it yet another way. What if we did 84 is the product of 6 and 14? Okay, because 14 times 6, 6 times 4 is 24. 6 times 1 is 6 plus 2 is 84. So yes, that works out. I know that to be true. Well, again, we want to end up with nothing but prime numbers. So 6 is not prime. It's a composite number. So let's break it down into 3 times 2, both of which are prime. And then 14, 7, which is prime, times 2. So there we go. We have a 2 times another 2 times a 3 times a 7. Again, no matter how you break it down, so as long as you're not making something up, meaning you're doing real math, you're not making mathematical mistakes, you are always going to end up in the same place. Why? Ladies and gentlemen, remember, the opposite of a prime number is a composite number. A prime number is a number I cannot break down anymore, but a composite number is a number that is composed, think of composite, composed of other numbers. Specifically, composite numbers are composed of prime numbers. Think of composite numbers like 84, think of them like a cake or a pancake or some kind of pastry that you are making that has a lot of different ingredients, okay? Because you don't go out into the wild and hunt down cakes or find cakes growing on trees. It doesn't work that way. You have to get the prime ingredients, like eggs, the flour, the sugar, the milk. All right, so think of the cake as a composite number. It's composed of ingredients, and the prime numbers are the ingredients that you have to put together, in this case, multiply together to produce the composite number. I hope that doesn't confuse you. I hope that actually helps you, and if it doesn't, then forget it. Just remember, composite numbers, I can break them down. Prime numbers, I cannot break them down further into other composite numbers. That's pretty much it. Again, there are other ways of breaking it down, but it doesn't matter which way you go, you are going to end up with the same prime factorization, and this is how we write it down. With that in mind, ladies and gentlemen, let me offer you some guidance as far as our homework assignment for today. So if we go down to our OneNote notebook, if we go to the 2-1 prime factorization tab, we are to do numbers 1 through 4 and then number 6. And what I encourage you to do, is to circle the numbers that you're supposed to do so that you don't miss them. All right, and so I'll do that here with you, and then I want to go over a couple of them with you. So the numbers that we're supposed to do are the numbers 1, which are going to be A, B, C, D, E, F, G, H, I, and I'll explain that to you in a little bit. Number 2, number 3, number 4, and number 6. So number 1, we're just doing what we were doing in the examples earlier. For example, number 1A, so in my notebook, I would write 1, and then I would write A, so I know that that's the one I'm doing. And we start with the number 14. So we're going to make a factor tree. That's when we have the little branches, just like we were doing. That's called a factor tree. And 14 is not a prime number. It is composite, and it is composed of 2 and 7. Now, both of these are prime numbers, so that's it. My answer would be, and I would write it down like this, 2 times 7. This is what it means to show your work, ladies and gentlemen, to make the actual factor tree. And then to have the final multiplication of those things. In fact, on Schoology, you're going to find a blank and then like a multiplication X and another blank. And as you fill in those blanks, you would put 2 and then the 7, and that's it. All right. If we do another one, let's say we did B, which 1B is going to be 30. Again, 30 is not a prime number. It is composite. And I'm going to go the route of, let's do 6 times 5. You can also do 10 times 3, but I'm going to do 6 times 5. So 5 is prime, so I'm done. I cannot go further. But the 6, I'm going to break it down into 3 times 2, both of which are prime. Awesome. So my prime factorization would be 2 times 3 times 5. Again, all I did is I put them in order. Not that if you put them in a different order, like 3 times 2 times 5, technically that is still correct, but it's just not very neat. Let's organize them. So I'm going to ask you to put them in the right order on Schoology as well. All right, so that's what you're going to do for all of these. Do you pay attention to F, though? Because F, they're asking you, well, what's the prime factorization of 41? Problem is that 41 is a prime number. The only factors it has are 1 in itself. So as an answer, just put 1 times 41. That would be your prime factorization. Even though 1 is not a prime number, 41 is already a prime number, so just leave it like that. The rest of them, though, these are all composite numbers. You can break them down further into their prime factors. Okay, number 2, why is every prime number greater than 2 an odd number? Why is every prime number greater than 2 an odd number? Well, consider the list of prime numbers that we did here. Okay, we said that 2 is the smallest prime number. I mean, that's true. But it's the only even prime number. All the rest, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, etc., all the way going up to infinity, all of the prime numbers are odd. Well, it makes sense. I'm not saying that all composite numbers are even. That's not what I'm saying. But consider numbers like 4. All right? 4 and numbers like 6 and 8 and 10, all of these numbers that are even. All even numbers can be divided by 2, right? And because they are divisible by 2, they will never be prime numbers. They're divisible by something else other than 1 itself. Again, number 4, yes, 1 and 4, but I can also divide it into 2 times 2. 6, yes, 1 and 6, but I can also divide that into 3 times 2. So it's not prime. All of these have 2 in common. Same thing with 8. I can do 2 times 4. Same thing with 10, 2 times 5. Same thing with 14, 2 times 7. So that's why all prime numbers except for 2 are odd, because odd numbers are not divisible by 2. I'm not saying that all odd numbers, because of course 9 is not divisible by 2, but it is 3 times 3. So it is a composite number. But again, just remember, if they're larger than 2, really all prime numbers except for 2 are going to be odd. And the reason why, because every other even number is divisible by 2. There's going to be similar logic in number 5. I'm going to let you try that on your own. But it's asking the question in number 5. Well, what about the numbers that end in, sorry about this. What about the numbers that end in 5, like 15, 25, 35? Why are these not prime numbers? Think about it. All right, number 4, it says list all the prime numbers from 1 through 50. Ladies and gentlemen, I already did more than half of this for you. Remember when I told you I listed the numbers, the prime numbers beginning with 2, because 2 is the smallest prime number between 1 and 50. I listed them all the way through 29. Just keep going. But whenever you list these numbers on Schoology, make sure that they're listed in order and that you don't skip any, because if you do that, it is going to mark them wrong. So just keep going after 29. Ask yourself, okay, so 29 is a prime number. What about 30? Is 30 prime? No, because I can divide it by 10 and by 3. What about 31? Okay, 31 is, so that's going to be the next one. So 31 is the next one. All right, what about 32? No, it's even. 33? No, I can divide it by 11. 34? No, that's even, so I can divide by 2. 35? No, I can divide it by 5. 36? No, it's even. 37? 37 is the next one. 38? No, that's even. 39? No, I can divide that by 3. 40? No, that's even. So just keep going and ask yourself until you get to the last prime number before 50, because 50 is obviously not a prime number. Okay, and then finally, number 6, I'm going to let you wrestle with that. All right, ladies and gentlemen, that's pretty much it. Again, fast forward or rewind the lesson, pause it where you need to, whatever you need. I hope that you find this helpful, and I will see you at our next lesson. Goodbye.